Hey, so this is section 2.2, Evaluating Limits. And in this video, we're going to go over how we can graphically represent limits. And so this problem that I have here is actually some bonus material. It's not found in your book, but it's similar to questions 51 to 54 in your textbook. So this question asks us to sketch one graph that satisfies all of these given limits. So the way we approach these types of problems is we go through each limit step by step, put them on our graph, and then we're just going to connect everything all at the end and have one big graph. All right, so our first limit says the limit as x approaches 1 of f of x is equal to 2. So that means as our x values are approaching 1 from both sides, our y value is going to be approaching 2. So we go to x equals 1, we go up to 2, draw a circle. Doesn't matter what the left or the right hand side are doing really, as long as x is approaching 1, the graph is going to y equals 2. All right, so we have our first limit done. Then we go to the next one. It says the limit as x approaches negative 3 is equal to infinity. So we're going to go to x equals negative 3. Since it's approaching infinity, that means that there's actually a vertical asymptote there. And from both the left and the right-hand side, our graph is approaching infinity. So we're going to go from the right-hand side, it's approaching infinity, and from the left-hand side, it's approaching infinity. All right, then we go on to our next limit. The limit as x approaches 3 from the left-hand side, the superscript minus means from the left of f of x is equal to 4. So we go to 3, and from the left-hand side, the graph is approaching 4, which is right there. I'm going to connect these two. And then our last one says the limit as x approaches 3 from the right-hand side of f of x is equal to 0. So 3 from the right-hand side is going to 0. All right, so I drew out all of my limits, but there's still one more step because what I have here makes this function not valid. Right now, I have 2 different y values at one x value. So I need to fix this. And the way you fix that is you just add an open circle. I can add an open circle here. I could have added it at this point. I could have added it at both points if I was feeling really wild. It doesn't really matter as long as it's not defined at both of those y values. But other than that, that's really the end of this problem. Your graph might look a little different from mine, and it doesn't matter what the middle parts look like as long as all the limits that they gave us are the same on both of our graphs. But other than that, that's it.